Hello, welcome back to another video. Let's take a look at these function questions. The question reads, given f of x equals x minus 2 and g of x equals 3 over x, which are not drawn to scale. A and B are points of intersection. DF is perpendicular to the x-axis. Put points E and F on the graphs of G and F respectively. Question 3.1.1, determine the coordinates of point C. Point C, we can see quite clearly, it is the y-intercept, and it is specifically the y-intercept of the straight line. The straight line has a function, or has a formula, x minus 2. So 3.1.1, if we want a y-intercept, we make x equal 0. So if our equation is y equals x minus 2, then y equals 0 minus 2. That means y equals negative 2. Since they want a coordinate, you write it in coordinate form. C is going to be 0 and negative 2. Question 3.1.2. Determine the coordinates of A and B. Now, A and B are what we would say are the points of intersection of those two functions. And if you're solving for the point of intersection or points of intersection, you equate the functions. Okay, so we have a function y equals x minus 2. So we would say x minus 2 is equal to, the other function is 3 over x. So 3 over x. Now what we can do is we can multiply by x on both sides. So x into x minus 2 equals 3. Now we expand x squared minus 2x. Bring the 3 over, minus 3 is equal to 0. Now we factorize x minus 3, x plus 1 equals 0. That means x is equal to 3 or x equals negative 1. Now both of these are valid because remember you have one x value that's on the negative side of the x-axis and one that's on the positive side. So this value here will have an x value of 3 and this one will have an x value of negative 1. So if we want the y value, we substitute it back. So we will say that y equals x, let's use the simple one, x minus 2. If we know x is 3, we're going to say y equals 3 minus 2. That means y is 1. So the coordinate will be 3 and 1. The other coordinate will be y equals x minus 2 minus 1 minus 2. That's minus 3. So the other coordinate will be negative 1 and negative 3. Okay, so we've got our coordinates. Next question reads, determine the length of EF if OD equals 6 units. Okay, so they want to know, what is this length right here if the length from here to here is 6? So what we can do is that since this is measuring from the origin, it means that this D coordinate is going to be 6 and 0. Since this line or this dotted line is perpendicular, it means that point E and point F are going to have x values of 6. And what we can do next is we can substitute those points into the respective equations to get the corresponding y value. So for instance, if we want this one, that's the straight line. So y equals x minus 2. We know the x value is 6. So 6 minus 2, that's 4. So this point here, the y value is 4. Okay? Then for this point, the equation is y equals 3 divided by x. Remember, we know x is 6, so 3 divided by 6, which is half. That means this point is a half. So we have a line now that has the following points. So let's redraw it here. You have 3.1.3. We have a line. This point is a half in length. This point is 4. So if you want the length of this, or the height of that, the height, but let's just write it as it is. It's FE. So that's F, that's E. So FE is going to equal 4 minus half, which is 3.5. So that length is 3.5. Okay, next question, 3.1.4. Determine the equation of J if J of x is equal to G of x plus 2. This one is, it's a shift. So the equation is going to be J of x is equal to G of x, and we know that G of x is the hyperbola. So 3 over x and then plus 2. So that's the equation. That's all you need to do. And then 3.1.5, the question reads, calculate or determine the values of x for which f of x is greater than or equal to g of x, where x is less than or equal to 0. Okay, so let's clear this space up now. Let's highlight our functions. So let this one, the hyperbola, be green, and let the straight line be yellow. Okay, so let's undo this. The straight line was yellow, and the parabola is green. So again, they are looking for which f of x is greater than or equal to g of x. In other words, they want to know where is the yellow line above the green line. And we are limiting this to where x is negative. So we are looking in this region, going that way. We want to know where is the yellow line above the green line. So if we look closely, in this area here, in this space right here, the yellow line is greater than or is higher than, or is above the green line. So what are these points going to be? We know that's 0, and this a value we worked out is -1. So this is -1. So when x is between -1 and 0. So that's our answer. So 3.1.5, when x is between -1 and 0. Okay, let's move on. The next question reads, sketch the graph of ax squared plus q if it is given that the range of h is that. Okay, so seeing that this value here, this right here, is a square bracket, it means it includes this value, right? So it is from -4 all the way up to infinity, and it includes -4. Okay, then it tells us that the a value is positive, and in a parabola, if the a value is positive, it means that it is a smiling face parabola. The q value is negative. That means that the y-intercept is negative. Next, they tell me that 1 root of h is positive and 1 root of h is negative. Okay, so roots mean x-intercepts. All right, so let's start. We'll sketch our Cartesian plane. We'll draw out our Cartesian plane like so. That's the x-axis, that's the y-axis. They tell us that the range, meaning the y values, are from -4 all the way up to infinity. So we will put -4 and we will include this. We know that it is a smiling face. So if we draw in that smiling face, remember it does touch -4 because it does include -4, like so. Let's check if everything else then falls into place. Is the y-intercept negative here? Yes, the y-intercept is negative. Do we have one root being positive and one root being negative? Yes, we do. We have a positive root here and we have a negative root here. Does the graph continue all the way up to infinity? Yes, it does. So that's our answer. Okay, question 3.3. Given g of x is equal to 3 times 2 to the power of x minus 12. So this kind of function is called an exponential function. 3.3.1 reads, write down the equation of the asymptote of g. Now the asymptote is given by this last value here. It is the line that it's not going to cross. So in this case, it's going to be y is equal to -12. Okay, let's move on. Question 3.3.2. The question reads, determine the y-intercept of g. Now, if you remember, if you want the y-intercept, we make x equals 0. So in this case, we're going to have y is equal to 3 multiplied by 2 to the power 0 minus 12. 2 to the power of 0 is 1, so it's 3 times 1 minus 12. That is -9. Okay, next question reads, determine the x-intercept. So 3.3.3, if you want the x-intercept, you make y equals 0. So now we're going to say 0 is equal to 3 times 2 to the power of x minus 12. Take the minus 12 across, you're going to get 12 equals 3 times 2 to the power of x. Divide both sides by 3. You're going to get 4 is equal to 2 to the power of x. That means now you can rewrite 4 as 2 to the power of 2 equals 2 to the power of x. Drop the bases, 2 is equal to x. So the x-intercept is 2. Last question, sketch the graph of g. So 3.3.4. So let's understand here, we have our x and y axis, like so, x and y. We know that the asymptote is y is equal to -12. So -12 is here. The line cannot cross this. We know that the y-intercept is -9. So -9 being here. And then we know that the x-intercept is 2. So 2. And now, since we know the intercepts, we know the asymptote, we can then draw in the graph. And remember, an exponential graph will look like this. And particularly, again, the b value is positive or greater than 0. And that's how our function is going to look. Okay, and that's it for this paper. I hope you found it useful. If you did, please leave a like, share, subscribe. And if there's something specific you'd like me to do, let me know in the comments below. And I'll see you in the next one. Bye-bye.